Hello, my name is Emma Frank, your regular tutor. So in this package, we are going to look at real sequence and series. But before we start, let's look at the format of the teaching. At the end of this teaching, the students should be able to know what sequence means. They should be able to know what series also means. They should know arithmetic progression, that is AP. They should know geometric progression. They should also know the sum of AP and the sum of GP. They should also know sum to infinity. They should also know how to solve problems relating to these topics, as we are going to look it in a wider scope. Definition of sequence. Definition of sequence. A sequence is a succession of terms by a well-defined rule. The rule for a particular sequence may differ from others. Example of sequence: we have 2, 5, 8, 11, 14. We can also have 20, 17, 14, 11, 8, and continue. We can also have 2, 4, 8, 16, 32. It continues. Now we have said that a sequence is a succession of terms by a well-defined rule. The rule for a particular sequence may differ from others. So, example, we put this. Now, let's also talk about series, because we are saying sequence and series. So, let's look at series. What is series? A series is the addition of the terms of a particular sequence. If you add all the terms in a particular sequence, then we call it series. That means the example above, example 1, the series is 2 plus 5 plus 8 plus 11 plus 14, and it will continue. For example 2, we have 20 plus 17 plus 14 plus 11 plus 8, like that. Same thing happens to example 3, 2 plus 4 plus 8 plus 16 plus 32. Now, that is a series. So that is all what we mean by series. But we are going to look at arithmetic progression. Arithmetic progression. This is a sequence in which the first term, comma, other terms are got by the addition or subtraction of a constant number. Let me underline that word because we are going to deal with that. If you know this one, in fact, operation of arithmetic progression, also known as AP, will be very simple for you. Constant number. You see, other terms are got by the addition or subtraction of a constant number. The constant number is called common difference. We denote it by D, common difference D, while the first term is denoted by A. First term is A, and then the common difference we denote it by D. Now, what am I trying to say? Let's look at this thing, and we also come back to our sequence, because we said this is a sequence in which, apart from the first term, other terms are got by the addition or subtraction of a constant number. Now look at that. So here, you see this sequence, we have 2, we have 5. For us to get 5, what do we have here? We add 3 to 2, so we get 5. We add 3 again to 5, we get 8. We add 3 to 8, we get 11. We add 3 to 11, we get 14. So it is taking that pattern. That is the rule we are talking. That the sequence is a succession of 10 by a well-defined rule. So now that constant number, that 3 is a constant number. So the constant number is called the common difference. While the first term, the first term is denoted by A. So this first term is denoted by A. So the 3 that we are adding is called common difference. Now, if we look at sequence 2, you see sequence 2, we have 20, then we have 17, we have 14, we have 11, we have 8. That means sequence 2 is got by a particular rule of minusing 3. 20 minus 3, you get to the 17, minus 3, 14, minus 3. So that is the rule. But look at this one. This one is not arithmetic progression, because we define arithmetic progression as a sequence in which, apart from this first term, other ones are got by adding or subtracting. So in this one, we have 2 here. So for us to get 4, we multiply 2 by 2, we get 4. Multiply 4 by 2, you get 8. Multiply 8 by 2, you get 16. So this one is not arithmetic progression. This one is called geometric progression. So when we finish arithmetic progression, we are going to look at geometric progression also. But we can now know what the first term means and the common difference means. So we are going to look at the nth term. The nth term of an AB. That is the next subtopic, the nth term of an AP. We are looking at the nth term of an AP. Now, the nth term, we are talking about a formula that we can use to get an AP. Now, if we have said that the first term of AP is denoted by A, it means, okay, let T denote the term, Tn denote the term, so that T1 will be equal to A, because that is what we said, that the first term will be A. Now, T2 will be equal to A plus D. Like this one, this is the first term. So what happens to the second? It will be A plus D, that is plus the common difference. So we'll have this one, A plus D. Now this one, which is the third term, will give us A plus 2D. So third term will be A plus 2D. The same thing happens if we go to the fourth term, as T for 4, we will have A plus 3D, that is 3 times the common difference. So T5 will be A plus 4D. Now we observe that at each term that we want to get, it is A plus n minus 1d. Yes, n minus 1d, because n here is 3. So we have A plus 2d, that is 3 minus 1d. So we can conclude that Tn is equal to A plus n minus 1 of d. So that if I want to get maybe T10, I will know that it is A plus 10 minus 1d. That will give me the 10th term. Alright. So this particular one is called the nth term of a sequence, where A is equal to first term, like I said, first term, and then D is the common difference. Yes, so that is the nth term of a sequence. And then we are going to take example of this. Let's take example. So the example is this. The first term of an AP is 3 and the common difference is 4. Find the sixth term of the AP. So solution, we have, from this formation, the first term of an AP is 3. So A is equal to 3 and the common difference, which is D, is equal to 4. We are asked to find the sixth term, which is T6, and we know from our formula that is the nth term of an AP. We have that that Tn is equal to A plus n minus 1d. Let me call this again, so that T6 will be what? T6, that is the sixth term, will be A, and we have A here. A is 3 plus 6 minus 1, D. D is 4. That's that. You see, we have 3 plus 6 minus 1 is this, 5, then times 4. Now, 4 times 5 is 20. So you see that T6 will be 23 as the system. And if you count this in, the first one is 3, and they say the common difference is 4, meaning that the second will be 7, the third will be 11, the next 14, If you count it like that, the sixth term will give you 23. So this formula is perfectly correct. Now, we also look at other subtopics. We are looking at tens formula for a particular AP. Now, I said that every sequence has rule or pattern, and one may differ from the other. We will see how it differs. Let's look at this sequence. If we have 4, we have 6, we have 16, and so on. We have 4, we have 10, we have 16. And then we are asked to develop a formula that we can get for this sequence. Now, we can do this by recalling our general AP formula, that is Tn is equal to A plus n minus 1 V. Can use this to develop this formula for this sequence that is going. How is it? You know that the first one is 4. So what we'll do is you have 4 plus n. We don't know the particular n yet. Minus 1. Then d. We have 4 here. We have 10. So the common difference here is 6. We also have 16. Common difference is 6. So you can put that 6 here. So that 4 plus 6 times n will give us 6n minus 6. Now we can also see that this will give us 6n minus 2, because 4 minus 6 will give us minus 2. And then if we want to further write it, we can write it this way: 3n minus 1. So we can say Tn is equal to 2 bracket 3n minus 1. If we use this particular formula for this sequence, whatever that we want to get, whatever term, we can use this formula to get. That's for a particular sequence. In another sequence, we can also have another formula also. But the general formula for sequence is that this first one that we have kept here. But every sequence or every AP or sequence in general, every sequence has its own particular formula that you can develop to get the terms in the sequence. So this is how we can use the general formula to derive a formula for any sequence. So the next one we are looking at is determination of A and T resulting in simultaneous equation. Sometimes questions like this will result in simultaneous equation for us to get A and D. Now, the question is this: example, in an AP, the difference between the 8th and 4th term is 20, and the 8th term is 1.5 times the 4th term. What is the one common difference to first term of the sequence? So we want to get the first term and also the common difference. Now look at the solution. The question says that the difference between the 8th term, so we have T8 will be equal to, the 8th term will always be A plus 7D. We know like that from what we started. We say it must be 1 less than the 10. 7D, that is 1D less than the 10. Now we also have T4 is the first term, which is A plus 3D. That is the fourth term. Now the question is that the difference between 8th and 4th term is 20. So that what we are saying is that A plus 7D minus A plus 3D will be equal to 20. And the 8th term is 1.5 times the 4th term. So that we also have the 8th term, which is A plus 7D is equal to 1.5 times. So 1.5 times is the same thing as 3 all over 2. That is 2 times 1, 2 plus 1, 3 all over 2. So it's equal to 3 all over 2. That's 1.5 times the fourth term. So the fourth term is this. So we have a plus 3d. Look at that. So now I want to call this equation 1. Also call this equation 2. It means that from 1 I will have a plus 7d minus a minus 3d, because I'm using this to multiply it, will be equal to 20. Now call that one equation 1. Now for equation 2, I have a plus 7d. Alright, it will be equal to 3 times this will give me 3a plus 9d all over 2. That's the equation 2. Which means if I cross multiply this thing like this, I will have 3a plus 9d will be equal to 2 bracket a plus 7d. Now this is 3a plus 9d will be equal to, this times this is 2a. This times this will give me plus 14d. Now this one is, I can collect items here now. So this will come here, or have that a as this will come here. So this is 3a and it will be minus 2a. So a will be equal to, this one is 14. So 14 minus 9d will give me 5d. So a is equal to 5d. Alright. Now, but from 1, that is equation 2. From 1, which is this one. If I collect items also, I have a here, I have a here. So that minus and this one will go. 7d and minus 3d. So we'll have that 4d is equal to 20. That is equation 1. Then d will be equal to 20 divided by 4, which is what? 5. If it is so, then from here, from 2, we have that a is equal to 5d. So a will be equal to 5 times 5. What do you observe? A is equal to 25. So we have got d equal to 5. We also have that a is equal to 25. Therefore, a is equal to 25 and d is equal to 5. These are the ways we can solve it. It's so simple. Okay, so let's look at another example. The fifth and 10th terms of an AP are minus 12 and minus 27 respectively. Find the AP and its 15th term. Now, we recall that the n term of an AP is given by Tn equal to a plus n minus 1d. So if it is so, the fifth term now will be a plus 5 minus 1d, that is d5 will be that, and they say it is equal to minus 12. Also, the 10th term, that is d10, will be a plus 10 minus 1d, and they say it is equal to minus 27. Alright. It means, let me call this one 1, and I call 2. It means that from 1, I can have a plus 4d is equal to minus 12. And then from 2, I have a plus 9d is equal to minus 27. So solving these things simultaneously, I'm going to subtract. Now this is equation 1, this is equation 2. So I'm going to subtract equation 1 from 2. If I do that, I will have 5d. I subtract this, 9d minus 4d will give me 5d. A minus 8 is 0. So I have 5d. Now 27 minus 87 minus 12 give me minus 15. So I have minus 15. So that d will be equal to minus 15 all over 5, which is minus 3. So d is minus 3. Now I'm going to put d is equal to minus 3 in equation 1. I put this in 1. So if I do that, I will have a plus 4d is equal to minus 12. So that a plus 4d is minus 3 is equal to minus 12. Times this, I have a plus minus 12 is equal to minus 12. So a is what? Now a is minus 12 plus 12. So a is equal to 0. It means that the first term starts from 0 before you can get other terms. Now the question is, we should find its 15th term, so that T15 will be equal to a plus 15 minus 1, that is the formula, and then d, our d is minus 3. And what is a? A is 0. So we have 0 plus, what is this, 14 times minus 3. Now 14 times 3 will give us, this is 2, and 1, 42. 14 times 3, 42. So we have minus 42. So T15 will give us minus 42. That is the 15th term of this AP. The next subtopic is sum of AP. Now, we know that the first term of AP is A, and that the second term is A plus D. And the third term will be A plus 2D. Then it will continue like that, like we know, till we have plus A plus n minus 1D. Yes, that is what we know. Because the last term will be given like this, just as that formula that we proved. So we will denote the sum by Sn, so that Sn, which means the sum, will be addition of the first term plus the second term plus the third term till we reach the nth term. Now, let me also start from here and add. I will also have a plus n minus 1d plus a plus n minus 2d plus it will continue again till I have plus a plus d, and then I also have a. You know, I'm adding from this side down also. Now what this means is, by the time I add equation 1 and 2, I add them together term by term. So what I will have is 2Sn, that's for this side, will be equal to, you know, this term will be going with this one. Remember, this one resembles the other one. So by the time we have, and this one is n minus 2, the next one will be n minus 3. So it appears that we observe that it is in n times, that it appears in n times. So we can say n times 2a, or this plus this, 2a plus n minus 1d. And if it is so, Sn will be equal to n all over 2, like this 2, of 2a plus n minus 1d. So this formula is used whenever we want to sum up terms of arithmetic progression. But suppose we are given the first and the last term, we use Sn will be equal to n all over 2 a plus n. Now this one is talking about the first and the last term. We also bring example that we can use this particular one. So example that we can use the sum formula is this. The first term of an arithmetic progression AP is 3 and the common difference is 4. So find the sum of the first 28 terms. Let's look at the solution. We have that A is equal to 3. It is the first term. And then D, common difference, is equal to 4. Now, remember that Sn is equal to 2a plus n minus 1 d. All over 2. So we are going to fix it here. That is S28, and this 28th term will be 28 all over 2. 2a, and a is 10, plus 28 minus 1 d, and d is 4. That's how simple it is. So that we will have that S28 will be equal to, of course, 28 divided by 2 is 14, and then we have 6, that is 2 times 3, plus 27, 28 minus 1, times 4. Now, that will give us 14. 27 times 4, we have 27 times 4. 4 times 7 is 28. We carry 2. We have 108. So this is 108. We have 6 plus 108. That will give us 14. 6 plus 108. 108 plus 6 plus 6 will give us 14. Carry 1. 1, 1, like that. 114. So we have 114. 114. So 114 will times 14. 14 times 14. 4 times 4 plus 16, that is 1. 4 times 1 is 4 plus 1, that's 5. 4 times 1 is 4. Then we have 4 times 1 times 4 is 4. 1 times 1 is 1. 1 times 1 is 1. So we have 6, 9, 5, 1. So that means S28, that is the sum of the first 28 terms, will give us 1, 5, 9, 6. Yes. We are looking at geometric progression, GP. So this is a sequence in which, apart from the first term, other terms are got by the multiplication of a constant number. Constant number. The constant number is called the common ratio, where while the first term is denoted by A, just as in the case of AP, first term is denoted by A. But in AP we have common difference. In GP we have common ratio. Alright. Now consider these sequences. When we started, we brought this sequence. We say that this first one is AP, because apart from this first one, other terms are got by addition of constant number. Addition of constant number. Sorry, but in the third one we have 2, 4, 8, 16, and then 32. Continue. Now we normally see that this one is not a sequence. The reason being that this one doesn't follow a particular pattern. But for this one, you see, this one is GP, because it is by multiplication that we have all these terms. Multiplication of a constant number, that is 2. 2 times 2 give 4, 4 times 2 8, 8 times 2 16, 16 times 2 32. So, but this one doesn't have pattern. Addition doesn't work. Because if I have 3 and have 4 here, then I say, okay, let me add 1 to get 4. Then how do I add 1 again to get 1? So it doesn't work. That's why we say this one is not a sequence, because it doesn't follow rule. So every sequence will follow rule. And then this one that follows the rule of multiplication, we call it GP. The one that follows the rule of addition or subtraction, we call it AP. That is just the difference there. So that is geometric progression. A sequence in which, apart from the first term, other terms are got by multiplication of a constant number called the common ratio. And also in this in series, what about series of geometry is addition of the terms. Let's look at the nth term of a GP. We have said that the first term of a GP is denoted by A. So the second term, how are we going to get it? We say A times common ratio, and that will be AR. Next, we will have T3, and then T3 will be A times R times R. No, times R will be 2, which is equal to A R squared. Now, the same thing will happen to T4. We'll have A times R times another R, which is A R raised to the power 3. And so we find out, we observe that Tn will be A times R raised to n minus 1, because in every term, you see, at the fourth term, we have here 3. The third term, we have 2 here. So meaning that it is reducing 1 at every term. So that's why we say, for any Tn, that it must be A times R raised to n minus 1. Alright. So that this particular one is called the nth term of a GP. That's the general nth term of a GP, or general formula for a GP. So we want to solve any GP. It is this formula that you must remember first. We can solve problems. And let's look at an example that we can use this formula to solve. So we look at this example. The sixth term of a GP is minus 2 all over 27, and its first term is 18. What is the common ratio? So let's look at the solution. From what we are given, A is equal to 18. as the first term. First term is 18. But we know that Gn for a GP is equal to A R n minus 1. A r raised to n minus 1. So the sixth term is equal to this. And its first term is this. What is the common basis? So we have that 6, that is this, will be equal to A r raised to 6 minus 1. Okay, and that will give us A minus r raised to 5. And they say it is equal to minus 2 all over 27. So that is A6. Now what it means is that since A is equal to 18, we will have 18r raised to the power 5 will be equal to minus 2 all over 27. Now it is the same thing as writing r raised to the power 5 is equal to minus 2 all over 27 divided by 18. Divided by 18. So that will give us r raised to the power 5 will be equal to, of course it will be minus 2 all over 27 times 1 all over 18, which is r raised to the power 5 will be minus 2 all over, then we have 27 times 18 will give us 486. Now r raised to the power 5 will be equal to 2 can go here 1 time, and then 2 can go here 2, 4, 3. So what we are going to do here is to take the fixed roots of this. R will be equal to the fixed roots of 1 all over 2, 4, 3. So R will be equal to minus 1 all over 3. How do I know? Because fixed roots means a number that you can multiply 5 times to give you this number. And you can see that 3 raised to the power 5 will give you 2, 4, 3. So 3 raised to the power 5. So R is equal to minus 1 all over 3. That is the common ratio I will say we should find. That is how it is done. Another example that we are going to look at is this. If x minus 2, x minus 1, and 3x minus 5 are 3 consecutive terms of the GP, find the possible values of x and common ratio of the progression. So we take the solution this way, and we know that for any GP to get the ratio, that the second term divided by the first term is equal to the third term divided by the second term. So what we do with this time is we will say that x minus 1 all over x minus 2 is the same as 3x minus 5 all over x minus 1. That is this divided by this is the same as this divided by this. Because if I have 2, 4, 8, as we had in the example, you see that 2 divided by 4, and 4 divided by 2 will give us 2, and then even 8 divided by 4 will still give us 2, which is the common ratio. So that is what we are doing here. And now, if I cross multiply this thing by this, I will have x minus 1 squared will be equal to x minus 2, and then 3x minus 5. So what it means is that x squared minus 2x plus 1, that is by binomial expansion. You expand this by binomial expansion, you have this. Will be equal to, this time this will give us 3x squared, this time is minus 5x, this time is minus 6x, this time will give us plus 10. So, x squared minus 2x plus 1 will be equal to 3x squared. This one is minus 11x plus 10. So we can now collect like terms. Collecting like terms here, we will have, this is x squared and this is also x squared. So if I collect like terms here, I will have x squared minus 3x squared. Then I have minus 2x. I also have here, I have plus 11x, because this turn to this side will turn to plus, will be equal to 10. Then this is plus. Going this way, we have minus 1. So what we have here is minus 2x squared, that is x squared minus 3x squared. So minus 2x squared, yes, plus 9x, because I have 11x minus 2x, give me 9x, will be equal to 9. What it means is that I want to avoid the negative sign, so I can write it this way: 2x squared minus 9x plus 9 is equal to 0. I just take this one that way, you turn to plus. Take this one that way, you turn to minus, and then this one already is here, so everything will become 0. Now, as it is, we are going to look for two numbers such that if we add the two numbers, we get minus 9. If you multiply it, we get the product of 2 and 9, which is 18. And we know that the two numbers are minus 3x and minus 6x plus 9 will equal to 0. So that is to say, you can now factorize it. 2x squared minus 3x. Then we'll have minus 6x plus 9 equal to 0. So if you do that, you can factorize what is common here. And then we see that x is common. So you have 2x minus 3. We also have what is common here. We see that 3 is common here. So you have 2x also minus 3, because this minus 9 will affect it. So we have x minus 3 is equal to 0, as these ones. And then we also have 2x minus 3 will equal to 0. So we have x is equal to 3, or x will be equal to 3 all over 2. Now, that is the values of x. That answers question number 1, one part of the question. And the common ratio. So to get the common ratio of this thing, we can now go back and say, to get R, to get common ratio R, when x is equal to 3, we now substitute it. That's so that R is equal to x minus 1 all over x minus 2. Because we said to get R, we must divide the second term by the first term. So x minus 1 all over x minus 2 will be equal to R. So when x is 3, you see R will be equal to 3 minus 1 all over 3 minus 2, which is equal to 2 all over 1, and it is equal to 2. So R is 2. When x is equal to 3 all over 2. So we'll have that r will equal to 3 all over 2 minus 1 all over 3 all over 2 minus 2. Of course, this one will be, if you take the LCM of this, you will have 2, 3 minus 2 is 1 all over 2. So you have 1 all over 2 divided by, take the LCM of this side, you have 2, 4. So we have minus 1 all over 2. So we have the downside is minus 1 all over 2. So this is the same thing as minus 1. So if x is 3, r will be 2. And if x is 3 over 2, r will be minus 1. So this is the ratio, and then we have got the value of x. That's how we can answer such question. Now looking at sum of GP, we have established a fact that the first term of any GP is denoted by A. So the second term will be AR, because we have to times it with common ratio, which is R. Alright? So we also have the third term that will be AR squared plus, we get it that way, we have AR raised to n minus 1. Now, let it be denoted by SR. Now, if we multiply it by R again, we will have R Sn will be equal to AR. Of course, that R will times we have AR plus AR squared plus AR cubed plus, it will continue again till we have AR n minus 1 plus AR raised to n. Now, if I subtract, let me call this one equation 1 and call this one 2. If I subtract equation 1 from 2, I will have R Sn will be equal to, of course, this will cancel this, and all of them will go. So the only one that remains is there. So we'll have this will cancel, we'll have Rn minus A. That is to say, I will have Rsn minus Sn. Rsn minus Sn, and then this will go. So we'll have AR raised to n minus A, because it's A that will remain. Now we see that Sn, R minus 1 will be equal to that. I'm factoring out Sn will be equal to A R raised to n minus 1 is still the same. So Sn will be equal to A R raised to n minus 1 all over R minus 1. Now this formula is called the sum formula for any GP. Now, we can also subtract equation 2 from 1. That is to say, Sn minus Rsn. It will be equal to, you have A minus AR raised to n. And what this means is that if we factor out Sn, now Sn will be equal to, you see that Sn 1 minus R will be equal to A 1 minus Rn. That is what we will have here. Now, as it is, making Sn the subject of the formula, will have Sn will be equal to A 1 minus R raised to n all over 1 minus R. Now, this particular one is used whenever R is less than 1. That is, if we have common ratio in a question and the common ratio is less than 1, we use this second formula. But when R is greater than 1, we use this one. That is when R is greater than 1. And this one is when R is less than 1. So these are the formulas that we use anytime we want to add GP. So let's take an example of this. So let's look at example. Find the sum of the first 6 terms of the GP 8, 24, 72. So let's take the solution. We see that A is equal to 8, and then R will be equal to 24 divided by 8, which is 3. So R is 3. Now, we know the sum formula that Sn for any GP because R is greater than 1. So we can use this the first formula here is the one we are going to use because R is greater than 1. So R is given by A R raised to n minus 1 all over R minus 1. That is to see that the 6th, I will want it, 6 term will be equal to A, and A is what? 8 R raised to n, that is 3 raised to 6 minus 1 all over R is 3 minus 1. It is the same as 8. Then we have 6 raised to, 3 raised to 6. 3 times 3 times 3 times 3 times 3 times 3 raised to 6 is giving us 729 minus 1. Now 3 minus 1 is 2. So it's the same thing as 8 times 728. Of course, minus 1 here. So give us 2. Now 728 times 8, giving us 5,824 divided by 2 will give us 2,912. So S6 will be equal to 2,912. So that's how simple it is when you use the sum formula. You can do it effectively. Infinity. Now from the formula that we have for Sn, we said Sn is equal to E bracket R raised to 1 minus R raised to n all over 1 minus R. That is when R is less than 1. So we are taking that formula now. Now what it means, sum to infinity, as n approaches infinity, as we sum to infinity, Sn will approach a definite value. Now look at it. When n is raised to n, when R is raised to n, there will be a time that n will be so big that what you have here will be small. It's just like having, maybe you have 3 all over 4, you also have 3 all over 20. 3 all over 4 is bigger than 3 all over 20. That is because 3 things, you divide it to 4 people. And that same 3 things, you divide it to 20 people. You see that this one will be very small. Okay, now, if n, so for instance, if R here is 2, and it raised to the power n, so when n is 10, you see that it will not be the same when n is 100. It will not be the same. So you see that as this formula is for when R is less than 1. So it's not even up to 2. So when R is, let's say, half, and then half is raised to 10. By the time it will raise to 20, by the time it will raise to 30, it's going up. You see that R will be very small. R will be small. So what will happen is that this place will turn to 0. And when that turns to 0, we will have A bracket 1, because this side is 0, all over 1 minus R, which is the same thing as A all over 1 minus R. Now, we have that Sn is equal to A all over 1 minus R. This formula now is used for sum to infinity, whenever you want to use sum to infinity. Remember that we are taking this formula from the formula of GP when R is less than 1. So, as R is less than 1, when n approaches infinity, the number will continue to decrease till we have 0 in this list. So we can now just times here, and then we have this. Now let's look at the example of this question. Two geometric progressions GPs have equal sums to infinity. Their first terms are 80 and 25 respectively. If the common ratio of the first is 4 over 5, find the common ratio of the second. Now, see the solution, how we are going to take it. We know that Sn to infinity is given by A all over 1 minus R. Now, let's take the first infinity, sum to infinity, Sn, which is 80 according to the first one. You have 80 here, all over 1 minus R. That is Sn1. Let me call that one 1. Now, Sn2, as for the second GP, sum to infinity, we have will be A all over 1 minus R, which is equal to 25. That's what they give, 25, all over 1 minus R. Now, the question is, if the common ratio of the first is 4 all over 5, so what do you observe here? See the first here. So, if R1, let me denote that one by R1, R of the first sequence is equal to 4 all over 5. It means we are going to put that here, and then we will have that Sn1 will be equal to 80 all over 1 minus 4 all over 5. It will be the same as 80 all over. Now this one will give us, I think this one will give us, let's take Sn. We will have 5 minus 4, but this is 1 minus 4. Will give us 1 all over 5. So we have 1 all over 5. Now, this will be the same as 400. That is using this 5 times 80 to give you 400. Divide by 1, you get 400. Now, but the question is that they have equal sum to infinity. Their first terms are 80 and this. So, if the common ratio of the first is this, we should find the common ratio of the second. So, what we mean is, since they are equal sum, so I would say that Sn1 is equal to Sn2, which is the same as picking this first one. And if you have seen it, that the first one is 400. 400 will be equal to the second. See the second here, which is 25 all over 1 minus R. So this is equal to this. So how do we do this? We can now cross multiply. If you cross multiply that, you will have 400 1 minus half, that is this times this, will be equal to 25. So that 400 minus 400 half will be equal to 25. I'm using this to times the average. This is to times the average. Now I'm going to collect items, so I will take this one to this side. If I take it here, I will have 400 half is equal to 400 minus 25. That is, I'm taking this one to this side. Now 400 minus that will give me half. 400 half will be equal to 375, because 400 minus 25 will give us 375. So half will be equal to 375 divided by 400. R will be equal to 25 can go here 15 times, and 25 can go 400 16 times. So you can see that if we divide this by this, R is even less than 1. So that is how we can solve such problem. With what we have learned in this topic, I really believe that you can use that to solve any problem in ray sequence and series. So get some problems, use this pattern and solve them. That are easier to solve, and they follow the same pattern. Thank you very much.